So hopefully you recall from our past few days of work that our formula is going to be volume is 1/3 times the area of the base times the height, okay? Now, that's our general formula. So this particular problem is having us figure out that there are so many cones with a height of 7, okay? So the first question that we have to do is write an equation that expresses the relationship between volume V and R, and they want us to use 3.14 as an approximation for pi, okay? So what we're going to do is we're going to write out the information that we know, okay? And we have 1/3 times, oops, my apologies, I don't want us using pi anymore. Well, I'll just write everything out. 1/3 times pi r squared times height, okay? So now, let's replace the information that we know. Okay, so I'm going to have 1/3 times, instead of pi, I'm going to now use 3.14 times my radius squared times, I now know that we are making predictions for a height of 7, okay? Now, this is perfectly fine, okay? However, I will tell you right now, as some of you are looking at it, it looks really, really, really nasty. So, here's what we're going to do. We're going to kind of clean this up a little bit by combining like terms. So the first thing that I want you guys to do is I want you to multiply 3.14 times 7, okay? And that's going to give us volume is equal to 1/3 times our radius squared times that 3.14 times 7 is going to give us 21.98, okay? Now, we're still not done yet, because we now still need to take 1/3 of that. Now, in order to take 1/3 of it, if you guys recall, you either multiply by 1/3 or you can divide by 3. And I'm going to go ahead and divide by 3. So I'm going to give us an equation of my volume is equal to, I'm getting a really, really nasty decimal, 7.326666, and it just goes on forever. So I'm going to round it to 7.33 times my radius squared, okay? And that is going to be the equation that we are going to use for number 1, okay? So I'm going to go ahead and cut this, okay? I'm going to go ahead and move it up there. That is going to be our equation for that. So all this extra work here, I'm going to get rid of because we don't need it anymore. And what I want you guys to do now is I want you to go ahead and answer question number 2. I want you to make a prediction as to what you are going to think is going to happen when you triple the value r. Okay, go ahead and do that now. Please keep in mind what we discovered happened in our other experiment when we were tripling the numbers. And, oops, did not mean to do that. What we're going to do now is we're going to graph all our possible solutions, okay? So now, first thing I want you to do is take a moment to think about what we are comparing here. We are comparing radius, and we are going to compare also the volume of the cone. So, excuse me, we've got our x-axis and our y-axis, and things are not going to be perfect, but I'm going to do the best that I can. So go ahead and label, or I should say type in what you guys think is going to be the x-axis and y-axis. And hopefully you said the length of the radius is going to be on our x-axis, okay? And the length, oh, I'm sorry, not the length, what am I thinking? Not the length, the volume of our cone, okay? It's going to be on the y-axis, okay? So we're establishing kind of a relationship here. What we're going to do is I'm going to kind of label things out for you guys. I want you to go every other on your x-axis and go 1, 2, 3, 4, 5, 6, 7. I'm going to run out of roll. Let's pretend that's a straight line. 8, and we'll pretend that one's a straight line as well. 9, okay? And then I'm just going to extend my graph a little bit. Okay. Yours will be perfect in your notebook. I just chose a wrong graph, okay? And what we're going to do also, we're going to call our volume of our cones. I'm going to delete this so I can have some space. You guys already have the answer. So we're going to go by hundreds. 100, 200, 300, 400, 500, 600, 700, 800, 900. I'm just going to kind of cap it there, okay? So, we have ourselves, I'm going to make ourselves a little table, kind of right here, where we are going to use our wonderful V equals 7.33 times r squared equation that we made up here, back at the top. And I'm going to kind of just plug in some numbers here to kind of I'm just going to plug in some numbers here to take a look and see what happens, okay? So, I have 1, and you guys could be doing this in your calculators as well. In fact, I'm going to want you guys to go ahead and do that, just to kind of make your own little table, so you can see how things happen. Okay, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So I have a length, and then this is my volume. Okay. So I'm going to go ahead and kind of plug away in things here. We're going to get, first of all, this is going to be 7.33. Obviously, it's going to be units cubed. Our next one is going to be, take 4 times 7.33. We're going to get 29.32 units cubed. And in case you're wondering how I got 4, remember 2, and then we square it in that equation, we get 4. And then our next one, we take our radius of 3, square it, gives us 9 times 7.33. It's going to give us 65.97. 4 is going to give us 117.28. 5 is going to give us 183.25. And you're going to notice now that our volumes are increasing quite drastically now. Our radius of 6 is going to give us 263.88. Radius of 7 is going to give us 359.17. Remember, all these are unit cube. Next one is going to be 469.12. And then finally our last one is going to give us 593. Okay? 0.73. So here's what I'm going to do now. I'm going to kind of mark these out. Let's go with a nice, bright pink. That'll help. So length of 1 is 7.33. So I'm going to kind of still leave that down here. Length of 2 is 29. Goes up a little more. Length of 3, 65. A little more still. Length of 4, 117. Okay, length of 5, 183. Length of 6, 263, so a way huge jump. Length of 7 all the way up to 359. Length of 8 all the way up to 469. And a length of 9 all the way up to 593. Okay, and I want you guys to kind of pay attention to how the line goes here. Okay, and I'm stopping here. I want you to take a moment and think to yourself, is this a linear line? Okay. It's actually not. So, now here's the question. We were told to take a look and see what happened. Question number 4, what actually happens to the volume if you triple the radius? Okay. So we're going to take a look at length 1 right here. Okay. Our volume for length 1 is 7.33. Now if I take a look at this volume 1 and I triple it, we triple 1 and that gives us 3. Our volume for 3 is 65.97. Okay? Now here's what I want you guys to do. I want you to take a moment and look at 65.97 and 7.33, and I want you to divide them. Okay? Once you divide them, what do you get? You should have gotten an answer of 9, which means that if we triple our length, okay, the same thing that happened to us when we were working, where are those notes at? The same thing that we were, I got rid of my square base. The same thing that happened to us on the square base, okay? When you triple your radius, okay, you are actually going 9 times the amount on your volume, okay? Mind blown, okay? So, I want you guys right now